Hello, my name is Tanai.
And I'm Taha Mulhami, and today we're going to present yapay zeka first homework.
Let's start with our necessary libraries. One of the important ones here is RE, which is used for regular expressions during text cleaning. Our first function is preprocess. And this function converts our text to lowercase. It removes punctuation, it removes the spaces, and then splits our text into tokens. So the output is basically a list of words that we will be using. The next function is load dataset, which reads the dataset folder author by author, and then for each one of them, it reads all of the text files and it opens them. It uses Windows 1254 encoding. It pre-processes them and then stores them into a dictionary. The structure of that dictionary is that each author name is the key and a list of tokenized texts are the value. And then after loading the data set we call split data, we will use 70% of the text for training, and then the 3 will be used for testing. After that, we have the build dictionary function. This function basically collects all of the unique words from all of the text and then stores them into a sorted list. This will be our search base for the genetic algorithm. And then we have to define n plus 50 initially, and then we will create the sorted author list. After that, we have create random individual function. It creates one candidate solution. And for each author, it basically randomly selects n unique words from the global dictionary. So one individual represents 9 word lists, which is one list per author. And then we have classified text function, which will be used to classify one text. So first, it counts how often each word appears in the text using counter. Then, for each of the author, it checks how many of that author's selected words appear on the text. And the author who has the highest score will be chosen as the predicted author. And if there's a tie, one of the tied authors will be randomly selected. And then we have evaluate individual. This function basically tests one individual. It classifies all the text, compares the prediction with the true, and then it basically calculates the accuracy. And so my friend now will explain how the genetic algorithm improves these candidate solutions over generations.
So here in the code solution, this function converts a numeric solution into actual words by using indices from dictionary. And then we got objective function. This function evaluates the results we got from the decode solution. Here we define the main genetic algorithm parameters. So we got population size of 20, 100 generations, mutation rate of 0.1, and elite count of 2. Then we got create population function to create the initial population by generating many random values or random individuals. Here we got the fitness function. It just returns the training accuracy of each individual. Here, for parent selection, we are using tournament selection with size 3. This means we randomly choose 3 individuals. We compare their fitness and we keep the best. And this process is repeated until we choose 2 parents. Then we got the crossover function. So for each author, we choose a random split. Then we use the first part of the first parent, and we combine it with the second part of the second parent. Then we check for duplicates. We remove them, but we keep order. And here, if the list is shorter than n, we replace them with random words from dictionary. For mutation, we use mutate function. So for here, for each author, we get or for each author, We get a certain probability for the word to be replaced by another random word for dictionary. And then again, we check for duplicates, and again, we check for the list. If it's not uh, equal to n, we fill it with random words. Here we got our main function. So for the first population, we created here using the create population function. And then for each generation, the fitness is calculated for each individual in the population. We keep track of the values, and we store the best fitness. After that, the population is sorted by fitness, and the top elite individuals are copied directly to the next generation. And the new population is created by repeatedly selecting parents and applying crossover and mutation uh, each time. And here, for the homework, we tested it with values like 50, 75, and 100, and then we plotted them. So my friend now is gonna explain values.
So here we have our two graphs, and we can see that n equals 50 gives us the best accuracy. Uh, and as n increases, our accuracy stays similar, but the test accuracy drops because the overfitting happens. A larger word lists memorize the training tests, but they generalize less. So the random baseline was, I think, about 16%. So our algorithm roughly tripled the classification accuracy. So that's it.